Second question from SK Enviros: the embedded carbon in the site infrastructure, which I think can contribute to up to 10% increase in turbine life cycle budgeting, is often flagged up as an issue. And is it possible to amend the model to include other site construction materials such as concrete, aggregate, steel, and sand? I think we might have touched on this briefly.
It was kind of answered.
Yeah. So I called it an impact unconsidered, but it may actually be considered in the model. I just wasn't aware.
There's a way of doing it.
Shout to see it done. Where did we put it? Yeah. Where is it? I've lost it. That's it, yeah, there we go. So, Dali derived some equations which she spoke about in her talk that can calculate this value from the values that are generally seen in different sites in the literature, but much better and recommended if you can get hold of that figure is to put in your own value. Now that value often comes from the part of the value comes from the turbine manufacturers, so you've got the infrastructure for the manufacture of the turbine, but that should also include the effects of concrete, you know, the input of concrete and different aggregates and all that sort of stuff. So that should actually be being calculated offline. But perhaps, as we said earlier on, perhaps we should include a worksheet in here to calculate, to help you do that calculation. But we haven't.
And should you take it out to the grid, basically a point which you connect into the grid,
Yeah.
should go all the way.
That should be accountable. Yeah.
And
So
you can put in that presumably then operational fuel, sort of construction fuel use and
yeah,
things like that.
that should all go into there. But we don't do it. It's assumed that you've done that because, you know, this is just one number that you put in. So it's really,
You can get the developers to do that. Quite a large scale.
Developments tend to not prefer stating one single turbine in an EIA.
sorry, what was that?
Developers don't tend to like taking it turbine specific because you don't know what's going to happen at time of EIA and time of construction. And you might be held to that. And then just
So
give a range.
they don't specify they're going to use Vestas.
It's normally just a hub and tip
Is that right?
and a minimum install capacity, and you might talk about your maximum grid capacity and then give a range.
You may have no idea where your grid connection is actually specifically going to be. You may know what line it's going to be on, but you don't know where it's going to be. And that planning and design process may be completely out of your hands. That may be being run by the grid provider themselves, the SSE. You've got a site where SSE themselves are doing planning for the substation of the site of application, which at the time of consent of the wind farm,
I
we
thought
weren't
this was
aware
all
of.
taken account on in the planning application. It wasn't the you know the I mean quite often, I won't talk about specifics, but quite often you see wind farm developments thrown out because they haven't got adequate connection to the grid. So this must be accounted for in the planning phase.
I mean, to some extent, yes, if it's obvious that you've got a wind farm somewhere where there is no feasible grid connection anywhere near, and that is clear to see, then obviously that's a significant consideration whether that wind farm should go ahead, because you'd be consenting a site that would be very highly unlikely to ever go ahead. But there's a scale there, and it may be that you know there was a grid connection line within a feasible distance that at a feasible cost. You just haven't put the pin on that yet for any number of reasons. So in that case, the planning authority may decide that yes, we can consent that scheme because we feel that there is a significant likelihood that that grid connection is achievable. Just maybe not, don't quite know the details of it yet. So there's a lot of things in this that, as a we're a consultant working for different developers, the developer didn't necessarily like to give us that information.
So you've got your worst case and your best case.
Yeah.
So, I mean,
But then you end up with a model that's got a lot of parameters in it that are worst case and maybe not that accurate.
Would it be in the developer's interest to try and give you the information if you felt it was really going to influence the payback time? Would it not?
Yeah, but then that brings it out into the wider discussion at a political level, as Scottish Government level, is how much weight is being given to this model. And this is one tiny aspect of the whole EIA
parameter, Joe?
What's the,
That one's that sensitive parameter in the model.
no, not particularly. I mean, if you look at the result, it depends what you're looking at. Obviously, it always depends what your particular example is, but I mean, this was a good simulation. I think what's the total payback time? This is the 2.3 years total carbon payback time. We're only talking about 5 months associated with the infrastructure overhead. It may be that if you were to do the calculations, that if you had a longer distance to the grid, that would significantly affect that. I don't know, I haven't done the calculations.
Probably though, if you had a longer grid connection, it would have more effect on the loss of peat or other embedded carbon in soils than it would actually. And that factor of calculation then it would have on the
I mean, as you put your
manufacturing.
pylons over the,
Well, actually.
or whatever.
I think that's a good example of where I think it's important using this as a tool for the IA to look at the cost versus the value, because in terms of actually working out the life cycle costs, that's quite an intensive process.
Yeah.
And if the contribution to the overall result is small, then where's the value in actually doing that?
Yeah, I mean, we do have also an input down here, which I cannot read what I'm on anymore. Somewhere. Cable trenches. So that's where it impacts the peak directly. So if you've got buried cables, then having the extra drainage around those cable trenches is given there. And if you've got very long distances to your connection, then you might have very large distances of cable trenches, which would increase your losses.
But you can backfill those with peat.
Pardon?
You can backfill those with
You can backfill them, yeah. So
Does it have such a, is the extent of drainage so large then, if you use the peat, I mean, does it have that negative impact? Is it, when you run that, if you put in like 2,500 metres of cabling, it's quite a high carbon impact. But if you're actually putting the peat back in, and you know the layer of sand doesn't act as a preferential flow line.
if the layer of sand doesn't act as a preferential flow line, that's the key
Design
point.
knows you would always put in bentonite dams at regular intervals to prevent the becoming a drainage channel.
Okay.
I've never seen sand being used in a situation where it's
Right. Okay. Then no problem. Just enter 0. If you can justify the reason why your cable trenches are not acting as drainage channels, then just enter it at 0.
Physically put dams in at regular intervals to stop them from
Yeah.
becoming
So
preferential.
that's fine. That's justifiable. So.
Can I just ask, my concern would be that if somebody's very conscientious might delve into the life cycle thing, and it's a well-known problem. The further you drill back to kind of, you know, the more embedded carbon you get, so the further back in the life cycle the more it can go. So I was wondering, would it be something